Hey there. Okay, so the last thing that I want to talk to you guys about, now that we've done basic object-oriented programming, instance variables, instance methods, and we've talked about locking down our classes, encapsulating them by making our instance variables private and using getter and setter methods to access the stuff that we need to access. I would like to talk to you about the concept of interface versus implementation. So if you take a look at the guide on the screen here, the interface of a class is this stuff. So anything that's public instance variables, public method headers, just the headers. That's the interface, right? That defines how you interact with the class. And I'm also including in here the java.comments, which tell you how those methods are supposed to be used and what those instance variables are for. So usually we don't even have public instance variables. So usually we have just public method headers and java.comments. That's your interface. So that is kind of what you publish for other programmers. You want to use my circle class? Here's the interface. There's a getRadius method, there's a setRadius method, and so on. And these are what the parameters are and what they're for. That's the interface, also known as the API, the Application Programmer Interface or Programming Interface. So the other programmers out there that are using your stuff are the application programmers. You're the person that created this particular class or this set of classes, and then application programmers are going to use it, and the interface tells them what they need to know in order to use it. The implementation of a class is everything else. So anything that's private instance variables, private helper methods, and anything that's inside the methods. So all of the method bodies, all of the code that makes the methods do what they do, and all of the comments inside that code, that's all implementation. And the programmer shouldn't have to know any of that stuff. Okay, and if you think about it, I mean, that's a really important and powerful way of organizing things. So the Java language itself is small, right, compared to the size of what we normally think of as the Java language. We include things like scanner and string and all these classes, thousands of classes that we use, graphics, context, and so on. But those aren't really a core part of the language. The core language is the keywords, the syntax rules, the rules on the semantics rules, the rules about what arithmetic expressions mean, how function calls work. That stuff is really, really basic stuff. That's the core of the language. And then the rest of what we commonly use is a huge set of classes, in most cases, written in Java by other Java programmers. So, so the scanner class, for example, the scanner class that we use to get input from the user, is just a class that somebody else wrote and we import and then we use. And what a disaster it would be if we had to know all the details and understand all the details about how nextInt works in order to be able to use it. Is similar with the graphics. Imagine if you had to know the algorithm by which they do a fill oval, or how that code, the implementation details of that code. It would be a bit of a disaster. We wouldn't be able to do anything. So, so this modularization is built in right from the beginning, and an important concept of that is that the fill oval method is like a black box. We just have the interface. We know what it's called. We know what parameters to pass in because of the java.comments that they've given us, and we can go into the Java FX API and we can see how you're supposed to use fill oval, and we have a description of what it's supposed to do. But beyond that, we don't need to know. We just need to know how to use it. Okay, so that's really important. So yeah, two big advantages to this. The first one I've just talked about is ease of use. We don't have to know how this stuff works. Somebody else has solved that problem. No need to reinvent the wheel. We just use their code. Another big thing that's kind of advantageous is that if you're working in an organization where you are building a large product consisting of multiple classes, what you have to do is you might have multiple teams working on different packages of code. So you're working on, I don't know, let's say the geometric shapes package, right? You're creating the circles and the rectangle objects and so on, and the polygon objects. What you have to do then is get together with the other teams that are going to be using your code and negotiate the interface. What do you want our code to do? How should the interface look? This is our proposal for what the interface should look like. No, they don't like it. They want it changed slightly. So you agree on that. And then once you've agreed on the interface, you fix it as much as you can, and then go work on the implementation. And you can come up with an initial implementation. So you write all the code bodies and the private instance variables and so on. And then later on change your mind and realize, the way that they're using it, this implementation is not as efficient as we thought it was going to be. So we're going to change it. We're going to take out some instance variables, replace them with other ones and so on, and change the code so that it still works the same way. But we're not going to touch the interface. So the interface is going to stay the same. And that allows you to make updates to your code without breaking code all over the system because you've made changes to the parameters and things that people need to pass. Okay, so let me show you this concept, this idea of changing the interface. So I'm going to go over to Circle 3 here. Circle 3 is fully commented with Javadoc. I'm going to add a little comment here. So I'm going to say changed in video to I'm going to say changed implementation. And my idea here is we're going to represent the diameter of the circle instead of radius. Okay, so we're going to change this from radius. We're going to rename it diameter. Okay, and then we're going to have to make changes throughout the code, how we draw the circle and so on. So we're going to make those changes, and we're going to do it without changing the interface at all. So without changing the public method headers. And without changing any of the other comments. I have changed this comment up here for you guys, just to reflect the fact that I've changed the implementation. What I would probably do there is just change the version number or something like that if I had an @version tag on here. So I just want to remind you what this thing does. So when we run Circle 3 test, let's run it and just take a look at the output. We get some system out here, and we also get this picture. So Circle 3 radius 50, location this, Circle 3 radius 100, location that. So just remember that and remember the output here, and we can go back into the video and look later. I'm going to change the way that this class works, the Circle 3 class works. I'm going to change its internals, but leave the interface the same so that when we're done, if I've done it correctly, we should get the exact same output, even though unbeknownst to the application programmer who wrote Circle 3 test, everything inside the circle has changed. Now, why would you change radius to diameter? It may be you're looking at how people are using your class, and you're realizing that they are doing things that use the diameter more than they're doing things that use the radius. So maybe they're checking the circumference of the circle, which you can get with pi times the diameter, more than they're checking the area, which you would use radius for. Which means maybe you're wasting a few cycles multiplying the radius by 2 over and over again. Maybe they draw the circle more than anything else. In which case, when you draw the circle, you want the diameter, because the oval is defined by the total size. So again, you're wasting time and resources somewhat by multiplying by 2. So we're going to change it to diameter. So we're changing the name of the variable for starters. Now there is I wanted to show you actually, if you ever change your mind about a variable name or a method name, you can highlight it, right-click, and refactor and rename. And you can I can now change this name to diameter. And the cool thing is it does in a smart way. It's much smarter than copy and replace. It finds all references to the instance variable radius. So ignoring local variables that might have the same name, and changes them. And I say OK here, and it changes them throughout. And it'll even change things in the comments for you, I think. Where's my, so get radius is changed to get diameter. Set diameter, and so on, and it's changed the comments and everything. So it's a really powerful little facility. I don't actually want to use it, so I'm going to undo everything, and so it should now go back to get radius and so on. I wanted to show you that because it's a really cool feature of the IDE. If you ever change your mind about a variable name. But we're not just changing the variable name here, we are actually changing the entire implementation. So I'm going to do it one piece at a time because we don't want to change, the point is we don't want to change get radius to get diameter. We want to keep that the same, keep the interface the same. So if the radius was 10 by default, then the diameter is 20 by default. So I'm going to make some changes throughout the code, and I'll be able to see my changes here. Get area. This will have to be now diameter divided by 2, and diameter divided by 2. Okay, so I'm just making little changes throughout the code, just to the implementation parts. Nothing to change here. This helps me too because I can look for red. So I want to check. Well, we can just check if the diameters are equal. That's no different from checking if the radiuses are equal. So this is my equals method. Then down here things change a little bit. So I was setting line width radius divided by 4, so that's going to have to be diameter divided by 8. X minus diameter divided by 2. Oh yeah, I forgot about this. So we're trading one problem for another. Now we can just use diameter for the width and height, but because I was drawing it using the center coordinate, using x and y as the center coordinate, I have to subtract the radius, which is now diameter divided by 2. So 6 of one, half a dozen of the other here. But and then here we've got get radius. We're going to leave get radius. So to the application programmers, it's going to look like we have a radius property, but we don't anymore. We have a diameter property. So diameter divided by 2 for get radius. Now set radius. So we are going to allow them to set the diameter, which is what we're representing, but by sending a radius parameter like that. Multiplied by 2. So this is going to be diameter divided by 2. And I think that's almost it. And then even the toString. We're not even going to change the toString. We're going to change this with diameter divided by 2. I don't think I need to, but I'm going to bracket this just in case, because we're doing arithmetic here inside of a concatenation, just to make sure that we do the division before we do the concatenation. So yeah, so if we, I can copy and paste this old output, notepad, put it here, just for comparison, and then I will run this again, and we'll keep our, oops, circle 3 seems to have some errors still in it. Good, okay, probably cut out most of that, but if I do cut it out, then you'll see an edit point, and the problem is that IntelliJ was glitching and showing me that there was an error in circle 3, but there is no error. Control Shift F10. I hope IntelliJ doesn't do that too often. Oh, I need to do Control Shift F10 on circle 3 test actually. So let's just double check. Yeah, okay. So I changed the entire implementation without anybody ever having to know about it. So maybe I made my class more efficient, maybe I corrected some bugs, but the interface didn't change, even though I quite radically changed the implementation by changing what a variable represents from being the radius to the diameter. Okay, and there's another example here. This is from the textbook, public class rectangle. Previously it had represented the area, so the old version of it up here, when we do set dimension, it computes the area and hangs onto it and then just returns that. But in the new implementation, it no longer has an area instance variable. It computes it every time they call get area. Pros and cons of that, what do you think? I'll let you guys think about that. Maybe we can talk about it in class. What would the advantage be of computing the area here and storing it and then just returning it here versus computing the area only when it's asked for and not storing it? What are the advantages and disadvantages of those implementations? Spoiler alert, they're going to be minor for most applications, but there might be some advantages and disadvantages. The last thing I wanted to show you is about documenting your interface. So I've got a big project over here, and not all of it is commented properly. So my circle, my sort of scratch code I was making here for you guys is not commented properly. But my week 3 code, I think it is pretty fully commented throughout. So every method has a Javadoc header with the correct tags in it and everything. What did I just do there? Okay, that's weird. I accessed some feature here of IntelliJ that I wasn't previously aware of. But every one of them has, oh, maybe I did this. Oh yeah, there we go. That's what I did. It's just another way of displaying those comments. Every one of them has a Javadoc comment, and here's where we can finally see what's useful about the Javadoc format. If we go over to, I believe it's code. No, it's not code, it's tools. And go to generate Javadoc here. What this does is it runs this thing called the Javadoc compiler. And you can say what you want included in your documentation. So I'm going to set it to private. Excuse me. I may cut out that sneeze. I'm going to set it to private here. And you can choose what tags you want it to show. I'm going to have it show the author tag here. And you need to pick an output folder. I think I ran this previously, so it's already picked. When you guys run it, you won't have an output folder here, so I'm just going to put it on the desktop in a folder called doc. Oops, /doc, like that. And it's going to generate a huge set of HTML files. And oh yeah, open generated documentation in browser. Actually, no, I'm going to turn that off. And I'm going to say OK. So this, it's going to pump out a bunch of stuff here. And then over here, there should be, here it is, a doc folder. And this is basically a website. So if I double click on index.html here, this is the documentation for my project. So it's gone through and read the whole project and stripped off the Java doc and arranged things for me. So if I go into week 3 code and go to circle 3, see this is the same as circle 2 but properly encapsulated. Circle 3. And you can also see it gave me the first sentence there, but this is my, let me zoom in here. This is my line that I added. It read the author tag and put Sam Scott there. And then here we have a field summary. So with each private field, and this is the text from my Java doc. Constructors, we can ignore that. We'll talk about that next week. Here are my methods. It tells you the type here, and then gives you a little bit of a description of what each thing does. Let's click on is inside. That takes you down here. And the parameters, you know, this is the other circle, and this is the what I wrote about how this function, what this function does. Determines whether or not this circle is inside another one. So if you go back here to circle 3, let's look at is inside. Here it is right here. See, the text that is appearing on that web page is the text that I wrote here. And then the other circle text came from the param tag. And the return value, where are we? Returns, here it is, true if this, oh, I have a typo, if this circle is inside the other one. That's because I wrote it here. So let's just do that. That's better. And let's do that again. Let's, where is it? Oh, it's under Tools, Generate Java Doc. I'm a bit of a perfectionist. So I'm going to regenerate the Java doc, and I should be able to just reload over here. There we go. That's better. Okay, so that's the method to the madness of doing this Java doc, is it generates for you this set of documentation pages in Java, official Java API format. So we've seen this format before. If we go over to, where are we? Resources. And we take a look at one of the APIs, like the official Java API here, you can see it once it comes up, that it's going to look exactly like the documentation that I produced over here for my circle classes. Yeah, I'm having so my kids are currently in online school downstairs, so it looks like I might not be able to load this. Got some internet access issues. But I'll let you guys do that on your own or go back to another video, and you can see that it's the exact same format as what we use here. So that the official Java documentation is generated using the Javadoc compiler as well. Okay, so let's take a look at the exercises. The final thing I want you to do with your object that you've been working on is add, properly Javadoc comment them and generate the Javadoc. And I would also like you to try changing the implementation of your object in some way. So, for example, track monthly instead of annual interest in a bank account, or change the type of the volume. If it was int, change it to W on your TV, or double to int. For students, store the final grade as an instance variable that gets updated whenever a new grade is entered, etc., etc. Okay, so find some way to change your implementation without changing your interface, and then run your main method again to make sure that it still works after you've changed your implementation. Okay, just going to check one more time to see if it's going to let me load this. Doesn't look like it. Okay, that's it for this one. Next up is the assignment, and then I will see you in the live class.